All right, so today we're going to take a look at slope-intercept form. We're just going to identify and learn how to write it. So this is just a way of writing an equation of a line when you're given two very, nice pieces of the line. So if we're given the slope and the intercept, we can very quickly, write it into this form. So down here you can see this kind of colorful little diagram here. So if y equals mx plus b, this is going to be a very, very important equation moving forward. You definitely want to commit this one to memory. It'll make your life so much easier when you're working on these types of equations. And even when we're working on other ones, this equation or this formula, or form, I guess I should call it, comes up quite a bit. So we have an input and an output. That is always what we call the x and the y. So when we've been dealing with direct variations and proportional relationships and all kinds of other ways that we refer to the same type of line, we have had an x and a y. So that part kind of continues to stay there. So x is the input, this is always the kind of what we choose, and then y is the output, what we get at the end. So that's always how the xy table is set up. M, what is being multiplied by the x, it's always being multiplied by the x, is our slope. And then the b, that is our y-intercept, so that's where the line crosses the y-axis. And slope, remember, that means the vertical change over the horizontal change. So we can think of that as rise over run, something like that. And in order to use this form correctly, it has to be y equals. There can't be anything else with the y. There can't be a number in front of it with a coefficient there. There can't be something added or subtracted. It just has to be y equals. And then it should be in the correct form from there. So if you look over here, we do have a little graph that shows us. So they gave us y equals negative 2/3 x plus 4. And they've got it in the same little color coding. Yay, that was nice of them. So I know on your notes page, when it gets printed out, you might not see the color on your notes page, but you can see it on the screen here. So with this one, we always start at the y-intercept. And I know when I'm gearing up to teach this, I relate starting point and y-intercept, starting point and y-intercept. I do it over and over and over again. I do that on purpose because we need to get that kind of drilled into our head. The y-intercept is our starting point. So we go to that 0, 0 point, which they're not showing you the whole graph. They're only showing you one quadrant here. So we go to the 0, 0 point here, and we just go up to 4 because it's positive 4, and we put our orange dot there. Doesn't have to be orange, but that's the color. Oopsie. Come on. It went backwards on me. So we put our orange dot, or whatever color you're using, and that is our first point. The second point we find with the slope. So we go to that number that's being multiplied by the x, and sometimes it's a whole number, sometimes it's a fraction. If it's a whole number, we put 1 underneath it because we need rise and run. If it's a fraction, then we already have rise and run. The top is our rise. Rise means we either go up or down, and run is either right or left. It just depends on is it positive or negative. So since we have negative 2, the rise is actually going to be a drop. We go down. So I go 1, 2, and then it's a run of 3. So from that 2, I go 1, 2, 3, and I put a dot there. I don't put a dot right here, but I put a dot right here. Remember, you have to do rise and run, and then put a dot. And then I just simply connect those two, and there's my line. So as long as we can identify slope-intercept and or slope and intercept, then we can graph this pretty easily. And they're just going to have us identify them for the first couple here. So y equals negative x plus 6. We're just going to go through and do that same thing. We're going to use this formula, and we're going to identify. So if we look here, the slope is always next to the x. So there we go. If we look at this, I see just negative. Whenever you don't see a 1 or any number, you just see either nothing or you see a negative. That means it's a negative 1 or just a 1 if you don't see the negative. So just keep in mind it's not nothing, it's a negative 1. And then the y is added or subtracted without a variable. So we just look for that number that's being added or subtracted, and that is our y-intercept. So let's try this one over here. So we're looking for that number being multiplied by the x, so it's negative 1/2. Even though it's out of order, that's perfectly fine. That doesn't change what we're looking for. I found, here's the x, that's my input, and what's being multiplied by it? It's negative 1/2. So even though it's not mx plus b, it's actually b plus mx, I guess. It was a little out of order. It's still okay. And then the number that's just being added or subtracted with no variable, well, that's the 8. Be careful, that negative belongs to the half, not the 8. The 8's positive. Look at what's in front of it, and that'll tell you if it's positive or negative. So be careful with that one. I have students accidentally go, well, it's being subtracted. Nope, it's negative 1/2 x. The 1/2 x is being subtracted, not the 8. So just be careful about that. All right, so let's look down here. Now we're going to just write the equation. So remember, we're still going to use this formula, and y and x are going to stay y and x. All we're going to do is plug in the slope and the intercept. That's it. So all we have to do is read the equation and say, write an equation in slope-intercept form for the line with a y-intercept -4 and slope 6. So I have those two pieces. The reason we leave y and x, is so that we have an equation that we can actually use to find other points. So once I have an equation written, I can say, well, if x is 1, I can plug it in and see, well, what is y? So I can find other points. So that's why we need x and y to stay x and y. I know I've said that a bunch of times. All right, so we're just going to plug this in. So we're going to have 6 for the slope. So instead of m, I wrote 6. And for b, I write -4. Now, Alex is going to make you correct this. It's not going to let you write plus -4. So you need to make sure you change that to just -4. Because it's not going to let you do the plus minus like that. So just keep in mind, this isn't technically wrong. It's just a little bit funky to have both of those operations, and Alex won't let you do that. It's going to make you type one or the other. All right, so now we're going to write one more. Write an equation in slope-intercept form for the line with y-intercept 2 and slope of -1/4. So same thing, we're going to use that same equation. So we're going to identify, here's our slope, here's our y-intercept. I'm just going to plug them in. So for slope, I'm going to have -1/2, and for y-intercept, I'm going to have 2. So here we go. And again, x and y stay x and y. We're not going to change those ones. Later, we may use them as a means to find one of these two other pieces, but we would have to be given a point to test something out. So right now, we're not changing those. All right. So that was identifying and writing an equation in slope-intercept form. I hope that helped, and I will see you in the next video.